Welcome to this DCC Open seminar. Digital Cellulose Center is a large Vinnova center, including academic partners, KTH, Linköping University, and RISE, and lots of companies in the consortium, including electronics companies, cellulose companies, and needs owners. This large Vinnova competence center it is in the second phase with a total budget of about 100 million Swedish crowns. And the vision in the center is to make cellulose-based products an integral part of a sustainable digital society. We work with 3 different value chains, including energy storage, medtech and health, and Internet of Things. And when it comes to energy storage, we are implementing and integrating things on a roll-to-roll basis, including supercapacitors and batteries. When it comes to medtech and health, we're working with conducting hydrogels and conductive paths within other hygiene products. When it comes to Internet of Things, we are carbonizing wood and wood components and like lignin and lignin celluloses to make them conductive. Today's talk will be about the EPOS, and it will be presented by Dagmari Belaine from RISE on green electronics. And I would like to leave the word directly to Dagmari. Dagmari, the floor is yours.
Thank you very much, Helmar. Thanks everybody for joining. So I'll just go ahead and share my slide. Do you see it?
We see it.
In full screen?
Soon. Now, yes.
Great. Okay, thanks Hjalmar very much for the introduction of DCC as well. I've been in DCC now from the beginning, so for 5 years. So it's great to have the continuation, also present the EPOS white paper here. The white paper is on green electronics components and systems. And I have given this talk at the title Towards Green Electronics in Europe because the paper is focused on green electronics in Europe. Before I start, I would like to begin with a personal note. This is an image generated by DALE, and for me, this symbolizes our situation, where we are in terms of electronics. So first thing is there's a huge amount of waste generated every year, more than 50 million tons per year. There is lack of clear legislation. There is a lot of clear coordination and partnerships. And there is also lack of knowledge overall. So, and when I say this, of course, it's not to belittle the efforts that are being undertaken. There are positive and serious efforts being undertaken in a lot of scenarios and in a lot of industries. But I feel personally that when we talk about green electronics and sustainable electronics, it should be said with a lot of humility because we are very, very far away from where we should be. So the paper by EPOS, which is the European Association on Smart Systems Integration, is titled ECS Sustainability and Environmental Footprint. But I'll start off by describing EPOS a bit. EPOS is a non-profit industry-driven organization that is represented throughout Europe. It has SMEs, research institutes, and the industry all involved in this aspect. And the vision of EPOS is basically leading the development and integration of intelligent and green smart system technologies and solutions for a sustainable society. So sustainability is a main theme of the EPOS vision. And when we talk about smart systems, it goes throughout this electronic components and systems. It starts from energy procurement and storage, sensing, processing, actuation, data communication, and also, of course, building a strong knowledge base and infrastructure to actually facilitate this transformation, the green transformation. In terms of the European context, EPOS does a lot of input. It makes research priorities. It writes, this is SRA's strategic research agendas, and defines roadmaps where Europe as a whole should go in terms of green electronics and other electronic systems as well. There is the capacity to acquire expert knowledge and develop infrastructure for knowledge development. And EPOS also advises policy approaches. And based on that, EPOS has had influence and a range of activities, including the KDT, Horizon Europe, making alliances, and of course, making a lot of events and initiatives to promote sustainability in electronics. There are a range of working groups and task forces in EPOS. So it's in total 8. Here I talk about key technologies, green ECS, AI at the edge, and transportation. The task force directly responsible for writing this white paper is the green ECS, and focused on where are we in terms of global context. Also, today, are we looking at cradle to gate? Are we looking cradle to cradle? And how can we improve that by incorporating a design model that promotes green electronics? And one of the very big focus of the paper was also how can we extend product lifetime through repair, for example. There are other task forces within EPOS in healthy living, factory automation, energy, food, agriculture, and natural resources. So EPOS aims to be an umbrella for all electronic components and systems and address each with a separate task force. So for this one, as I said, Green ECS working group, it's the same. It's composed of a research organization, SMEs, industries, and seeing how sustainability and environmental sustainability can actually be incorporated in electronics. The aim is to propose to the EU and KD proposals so that they aim for sustainability goals, make different focus groups within the KDT, write strategic research and innovations papers, and of course, like what I'm presenting today, write white papers that direct private and governmental institutions on where research should go, where technology should go in terms of green electronics. These are the partners which contributed. So we try to have a partner in all aspects of electronic components and systems, starting from materials and processes all the way to standards and regulations, softwares, eco-design. So RISE was involved in the integration, reliability, and eco-design aspects. Specifically, of course, we commented and we participated in all aspects of the paper, but those were the main areas we participated in as RISE. The paper was published in July 2023 for consultation. It was open until end of August, and it was finalized in September. So if you'd like, you can access the paper at the EPOS website, or you can also scan this QR code if you'd like. And I highly recommend that you take a deeper look. I'll give a highlight of the most prominent aspect. It's an around 80-page document, so there's much more information than I can present here. So I have divided my presentation in 4 sections. So where I talk about, where I roughly follow the table of contents of the paper. I talk about the global environmental context, and then I talk about today's situation in Europe. Where do we have problems? Where do we have improvements? I'll talk about specifically how can design help green ECS, and There's a 9R framework that has been established to facilitate this. And in the end, I will present the recommendations given by the paper in our push towards green electronics. And the whole umbrella, to start off, is the UN Agenda 2030, which defines, among many things, sustainability in terms of waste reduction. And most of you probably know that there are 17 Sustainable Development Goals that have been defined in this Agenda 2030. And as a consequence of this, the EU Green Deal came up, and the EU Green Deal has been followed a lot of legislative and regulative actions, including the Circular Economy Action Plan, the eco-design standards, and recently the product environmental footprint. And this all is interrelated, and the UN 17 Sustainable Goals explicitly talk about greenhouse gas emissions, which is also incorporated in the European Green Deal. So the EU Green Deal has a regulation of climate neutrality by 2050, and also the Fit for 55, which is reducing greenhouse gas emissions by 55% by 2030, compared to the 1990 levels. But we also have, when we look down the ladder, we have the 9R framework, which is supposed to guide Circular Economy Action Plan and life cycle assessment, which are being increasingly used in electronic components and systems, are also part of this regulation and standardization. So this is a slide probably with a lot of text, but I will try to focus on the central one, which is what are the challenges? And here we have identified, okay, there's challenges in design, there are challenges in manufacturing, there are challenges in the business models that exist today, and then there's challenges in the tools and infrastructures for circularity. In terms of design, it's clear that a well-designed product will promote sustainability, and we see that up to 80% of the environmental impact of a product is defined during the design phase. So there should really be a clear regulation from the EU that says, okay, your product should have this criteria in its design phase. So to reduce energy consumption and also material use of, could be critical materials, rare earth elements, and so on. So there needs to be a clear design, which is currently a challenge. In terms of manufacturing processes, there's high energy output and use of dangerous materials. For example, the previous talk on the DCC was about PFAS, perfluorinated or alkylated substances, which are defined as forever chemicals because they don't degrade. So there needs to be clear guidelines in terms of use of materials and manufacturing. In terms of business models, we have a very linear business model still. Circularity is not a model in a lot of products, and it's important to have an EU-wide regulation to also facilitate this. In terms of tools and infrastructure, there is lack of clear distribution channels, there is lack of knowledge, there is lack of transparency, and also it's getting better, but in terms of softwares and AI usage, there is also a lot to do to promote green ECS. And one thing which we also clearly identified was that when we talk about green electronics components and systems, there is green of electronics and green by electronics. So when you talk about green of electronics, we're strictly talking about the electronic products themselves. What kind of materials are you using? How much energy are they consuming? Are they top and high end? Are they efficient? Are they sufficient for the task at hand? So basically really looking at the product itself. But on the other hand, we have electronics itself facilitating sustainability in terms of, for example, environmental monitoring, using teleconferencing to reduce transportation and thereby greenhouse gas emissions, for example, and waste and environmental hazardous materials, release of hazardous environmental materials, and so on. So we have to keep an eye on these two aspects, because it's a double advantage if we are able to utilize both. And next, I'll discuss briefly the environmental context of how the paper defines where we are. So this I mentioned briefly in the beginning. There is a huge generation of e-waste, and this is 2019, so it's for sure more than 53.6 million tons by now. The estimate is around 2% per year. And I think by 2030, it's expected to be more than 70 million tons. And the most unfortunate part is globally, it's only around 17.4% that's recycled, and 82.6% is just wasted, which means that there's a lot of CFCs, brominated substances, and mercury being released into the environment. And of course, it means a lot of a loss of a lot of raw materials, estimated to be in the range of 60 billion USD. Look, globally, we have 12 million tons of waste generated in Europe. Asia has the highest, around 24.9 million tons, but of course that's because of the high population. Europe has around 16.2 kilograms per capita of waste. So an individual in Europe is responsible for around 16.2 kilograms of waste per year. In Sweden, it's more than 20. I think it's around 21 or 22 as of 2019. And in Norway, I think Norway has the largest. It's around 25. So it's a very big problem. We see that Africa has the lowest production so far, but that's also kind of deceiving because it's a population that's growing rapidly. It's supposed to double within the next 35 years. And it's also moving towards a more middle-class society, which means there is also an increased impact from growing populations in the near future. So today's situation, when we look at specific hotspots and also where we see improvements in the electronics and components and systems, one is energy consumption, and something that was clearly identified is that clean rooms where a lot of electronic products, especially high-end electronics like chips, are produced, are extremely energy hungry, and 60 to 70% of the energy consumptions of operations is actually in the clean rooms. Just to understand by the amount of energy clean rooms consume is huge. Furthermore, they use very strict workflows, which means there is a lot of waste in terms of solvents and different gases. So one thing clearly identified in the paper is that, okay, when we talk about energy consumptions in electronic sector, we have to really look at clean rooms specifically. In terms of improvements, the incorporation of highly recycled content, bio-based and biodegradable materials was something that was highlighted. And this is an image from VTT where we see how we can go from a less sustainable or unsustainable production, which is using non-biodegradable and fossil-based materials, to more bio-based and biodegradable materials. So we have these materials which are being made from fossil sources. We have moved on to biopolymers or biodegradable polymers, And here we see cellulose-based products, paper, cardboard, cellulose, lignin, which are both bio-based and biodegradable. So when we talk in terms of sustainability, indeed cellulose has those advantages of being environmentally compatible. And that's one of the improvements in the electronics industry that has been highlighted. Another aspect which is also quite related to the DCC that was highlighted in the paper is reducing environmental footprint through smarter processing systems or innovative processing systems. And one of them that was highlighted was this production of graphene by laser. So it's a 3D laser induced graphitization or graphenization. Just to go quickly over it, so it's using products from the forest and printing and graphitizing using a laser. So it's also very effective for flexible electronics because it's a printing technique, and it can be used for a range of applications, including here hybrid electronics or sensing humidity in different situations. So one aspect that has been highlighted is using innovative new processes by using biodegradable or renewable resources for electronics. One other aspect that was also highlighted in the paper is the use of life cycle assessments, which is becoming more and more used in the electronics industry. It was less so, it was quite big in the construction industry, but now it's also becoming more and more useful and used in electronics components and systems analysis, which is quite positive. And one thing, so LCAs basically look at resource input and environmental impacts output. And this is done by currently still to a large extent seen in this linear fashion where we start from the acquisition of materials, which includes mining, and then fabrication, packaging, use, end of life, and also attributing here the e-waste and its impact, environmental impact in climate change, toxicity. The ISO defines 16 environmental impact categories, and each product can be assessed and analyzed based on these categories to see if it's sustainable, or more sustainable or less sustainable compared to other products. So another aspect of the paper was how can we design, as I mentioned at the beginning, design is one critical factor, and how can we use design from the get-go to promote green electronics. And for that, there is this 9R framework that was developed, I think, in the early, like in 2016. It has 10 words with R's, which starts with refuse, which means do we need this? Is it safe? Is it sustainable? So one discussion going there is, an example is PFAS, all the way to recycling and recovering. And some of the words, like there is a lot of semantics, so we had a lot of discussions and debates on, for example, what repair is and what refurbish is. Is it a third party that is going to do the maintenance, or is it the primary vendor? So it's there was a lot of discussions, and then I'll quickly try to go through them or categorize them in their strategic domains, basically. So when we look at refuse, rethink, and reduce, we're mainly looking at like the design of the material itself. Can it be phased out? Can we make it more intensive, or can we increase its efficiency by consuming fewer natural resources and so on? So this really focuses on, as a strategic domain, on the design of the product that we're making. When we look at R3 to R7, it's reuse, repair, refurbish, remanufacture, repurpose. The main idea is how can we extend the lifetime of this product via giving the same product to a different user for whom this material is still functional and sufficient. For example, how can we repurpose products that are used for one specific purpose to another one where they're still functional and sufficient? So this 1, 2, 3, 4, 5 R's specifically address how we can extend the lifetime of products. And the last two, which are recycle and recover, focus more on the design of circularity. So recycling, I will come to it later, is also one of the main things addressed, and repairing is also another aspect which is quite well identified in the paper with details. So here we talk about material circularity. So from the previous image I showed on LCA, we now move on using this R framework to a much more elaborate structure for doing life cycle assessments. So now here we have the resources going in from the beginning, from materials processing, manufacturing, packaging, use, end of life. But now we have other arrows going. For example, if we're repairing at the end of use, we can repair and bring it back to use, or we can refurbish and bring it back to another stage, or we can repurpose or remanufacture to bring it to the previous stage. So now we have much more options to actually have circularity. So instead of this linear paths we have been taking, we have actually, using this R framework, a very good strategy and to rely on to facilitate this circularity. And reliability is another R word, but it's not part of this 9R framework. It permeates basically throughout the R framework. Whatever we do in this R framework, it's to make the product more reliable. So it can be considered as an umbrella. So at the end, what recommendations does this paper have for the transformation towards green electronics? And I address again the same aspects of design, manufacturing processes, business models, tools and infrastructures for circularity. In terms of design, it's clear, okay, we need to reduce and replace hazardous materials, for example, PFAS, and we need to replace or reduce the use of critical raw materials or the rare earths materials. We need to incorporate LCAs from the design phase so that we can identify hotspots from the beginning and make changes, and a range of other recommendations, including the 9R framework. Manufacturing processes, there are good signs that things are improving, but there are still a lot of improvements recommended in terms of using renewable and bio-based materials and maximizing energy efficiency. In terms of business models, increase repair and also establish repair index, for example, as inspired by the French repairability index. And in terms of tools and infrastructure for circularity, we have now a clear 9R framework which will facilitate the capabilities of the industry. There is a need to have a platform for collaboration and sharing knowledge, which the EPOS is also doing so in terms of sharing knowledge and being an infrastructure for the collaboration between different actors, SMEs, research institutes, and the industry. And of course, it's about promoting awareness and education on sustainability in the industry, but also to the wider public. And one thing, as I mentioned earlier, that was focused on was repair. When we talk about repair, it has three aspects. So it starts with characterizing what's wrong with this product and why does it need repair, and then actually repairing the product and recharacterizing it so that it's ready for use again. And the main obstacles in characterization are, for example, complexity of the product, knowledge of the person who's doing the repair, and of course, intellectual property, where a lot of things are shrouded in secrecy because of financial motives. And in terms of repair, knowledge is still another issue. Cost is another issue. The cost of repair should not be larger than the cost of the new product. And recharacterization, we have problems of warranty and proof of repair. But the drivers here are transparency in terms of characterization, having more information, bonus systems for repairability, and so on. And then in the actual repair, we need to have a business model which has repair as a business, or repair itself as a business. Availability of spare parts is very important, and the products should already be designed for repair from the get-go by having modularity as part of the design process. And for the recharacterization, the main aspect is legislative. So there has to be regulations that say, okay, these things need to be recycled or repaired in such a manner, and then this person carries the warranty for this many years, and so on. And that's lacking, but the main driver would be legislative. And the very good example that was given that's going very positive is the French Repairability Index, which is a 10-point marking for repairability. So it starts from 0 and goes up to 10, 0 showing not repairable and 10 showing highly repairable. And it has 5 criteria, and very importantly, it has price as part of the criteria, because this thing, as I said earlier, repairing should not be more expensive. And with this repairability index that France introduced in 2021, the aim is to reduce, to have 60% repair in the next 5 years. So that's the goal, and it's a clear, probably achievable goal that has been set. So also setting such legislative directions is very important, and the affected categories are also clearly stipulated. So mobile phones, washing machines, phones, and laptops, and so on. So it's very clear, and it's a very good example that should be followed within the rest of EU, and that has been recommended in the document. Yes, and these are the authors which contributed, and it was a couple of us, like 3-4 of us from RISE, and a lot of research institutes from France, Switzerland, Austria, Ireland. So it was a big group, and it was also a very productive and nice discussions. Before I finish, I would like to go back to the image I started with. I generated this image not only because I love elephants, they're my favorite animals, but it's because it also reminds me of the word or the expression elephant in the room, which is a metaphorical idiom, like to describe what we want to ignore, intentionally or unintentionally, even though it's very obvious. And this could be because it's awkward or uncomfortable, but it obviously affects the situation. And for me, when I think of elephant in the room, here it's me, or it's us. So we are the elephant in the room. Of course, I know there's a lot of people who are actively trying to reduce electrical component waste in ECS, but are we doing enough? Do I need 2 laptops? Do I need 2 tablets? Do I need 2 phones? Do I switch off my screen when I am away from the screen? Or yeah, so like, how am I responsible for this waste? Because 20 kilograms of waste, electronic waste, every year speaks for itself. So I think it's important to take some level of responsibility personally to actually address this problem and become sustainable citizens. You can access EPOS paper here. You can scan the QR code, or you can also, just go to the website. And thank you for listening. I hope you go and read the paper. Thank you. I can't hear you, Helmar.
Thank you very much, Dagmar. I was muted. Really interesting presentation. I'm looking forward to a good discussion here. If we have any questions from the auditory, we can start with them. Otherwise, I have a couple of questions. And I would especially like to invite people I haven't seen before, Christos, Daniela, Martin, and Mavis to the discussion. But I wonder if you could go back to one of the slides, the green ECS and the ECS for green. Yeah, so I didn't really get the left and the right column here. Could you please elaborate on it a little bit more?
Yes, so when we talk about green ECS, it could be, for example, a sensor. It could be a sensor made by laser graphitization. And then we're talking about how much energy goes into making the sensor, what kind of materials do we use in the sensor. So are those aspects of this specific sensor reliable and environmentally sustainable? But when we talk about the right aspect, ECS for green, it's what are we using this sensor for? Are we going to place it in a river to sense pollutants? Are we going to put it in the forest to detect variations in humidity? Or so it's how can we use this sensor for being more sustainable? So that's the difference between green of ECS and green by ECS.
And which one are you considering within this paper, in the EPOS paper?
It's both. So
both.
Okay. Yeah.
And the next question is slide 22, which I think is quite important for the DCC, the Digital Cellulose Center. 22 is the next one. Yeah, this one. So here you have the graph, bio-based and biodegradable. And here, obviously, cellulose-based, paper and cardboard-based is high up in the corner. But when it comes to sustainable, why is this more sustainable? I have the same question at hand, but I would like to ask you.
Yeah, of course. So one thing, when doing a life cycle assessment, the answer is always it depends. So the question is, it's bio-based and biodegradable. Is it sustainable? The answer is it depends. So it depends on how it's produced. It depends on the actual energy consumption and what kind of chemicals are actually going to the process. But in terms of environmental friendliness as an end product, it's more sustainable. So I understand where you're coming from. So it's not clear cut to say it's more sustainable.
But maybe I can rephrase myself a bit. You were also talking about the 9 R's, which is actually 10 R's if you count them. And I wonder
if you... It's another debate.
Yeah. But if you're including bio-based materials with electronics, does that increase cyclability or decrease cyclability?
I mean, yeah, it depends on how you make your product. So if you have made it in a modular structure where you actually can break it apart and then, okay, this is cellulose, this is lignin, I can just throw it away, it will degrade, it's good. But it has to be in a bigger umbrella of how is this designed holistically. So it's not very easy to say immediately. So it's cellulose, it's sustainable. So it's not easy, and especially now what we have noticed or what we have written in the paper is a lot of electronic components. They're minute. So maybe you use 0.001 gram of gold, which is important, but then how can you recover that? So there is a lot of challenges like that as well. So it really depends on the specific product and how it was designed to say it's more sustainable. Yeah.
Thank you very much, Dagmar. I can see maybe Daniela, would you like to ask something?
Yeah, hi. Sorry, I have a cold. So I actually work with Aidan Quinn in Tyndall, who contributed to that paper. So it's a very nice paper. So I suppose a few considerations maybe. You mentioned it depends on the process, but I guess also the application is important. And we have this continuous debate between conventional. We work a lot with laser graphitization, so the feedstock material could be a conventional fossil fuel-based polymer or could be a biopolymer. And I suppose where I would see the biopolymers like a winning is for those kind of low-cost disposable applications in which you would make a sensor that you would use for a short time and then you would throw away anyway. And I think in that sense, obviously, rather than accumulating non-degradable materials, then this is where the biodegradability could be a winner. For other applications like agri-food and monitoring of soil and stuff, where you would, I suppose, need a longer lifetime. I'm not sure yet how the two things would compare, but just a few thoughts. But
thanks, Daniela. I mean, we also work with laser graphitization, and here at RISE we use lignin. So like you mentioned, it's if you're valorizing a product that was just being wasted, so that's already a big push, and then you can also, like, the application itself or where it's used is also quite critical. So I agree.
Do we have any more questions? I have some more questions. In the beginning, you said 80% of a product's environmental impact is defined in the design phase. Is that only for electronic, the ECS, or is it for any kind of product?
I don't think I have. I mean, that 80% is for ECS when we mentioned it in the paper, but for any product, in principle, it's the large part of it, the design issue, I would say. So I wouldn't say it's 80% for like building materials and so on, but the design is, I mean, it goes from, do we need this, to can we recycle this and recover this? So if it's not considered from the get-go, then it will have for sure a big impact.
You also mentioned traceability. I wonder how digital passports may come into this. So digital passports as a way to follow and trace the full chain of the goods for electronic equipment, for example.
That has also been mentioned in the paper. Digital passports should be coming, but there's no actual legislating legislation stipulating what kind of a passport a product should have. Another issue is also that I didn't mention is right to repair, which has been proposed by the legislation, but it's also, I mean, it's being pushed more in Germany right now than anywhere else, but it's still not part of the EU legislation. So there is several such pushes. So I mean, one clear shift that we can see industries, for example, the mobile phone chargers. So now we have USB-C pretty much for all phones, and moving away from the old generation where each manufacturer can produce its own kind of charger. So that's also being pushed by legislation. So that there is a clear directive for that, and there is a clear shift. So it's always about legislation, and that's what EPOS tries to do. How can we make the lawmakers push for such?
Yeah, so and that's a good start to my next question. So what is the takeaway for the Digital Cellulose Center, for example? Is there something concrete we can work on to support the legislators to go in the right direction?
I mean, for one thing, I think the fact that the center exists by itself is great. So I think that's already a very positive indication that something, as we see in this image, something dedicated to cellulose or both bio-based and biodegradable materials is very important, and its presence itself is a good platform for change. And I think such seminars are important, raising awareness. I think also based on the experiences and the learnings from the DCC, having a specific white paper, for example, targeting biodegradable bio-based materials, and how that should be included in research calls or also legislations. I don't know what kind of suggestions you'd have for legislations on the use of biodegradable materials, for example. Should we demand a certain percentage of biodegradability from products and so on? So I think as DCC can actually think about these issues and say, okay, we need to define this framework so that the legislation also enforces it. So.
Also, when it comes to blind spots, now you've been working on the holistic page, as I see it. Is there anything that you left out that we could have a dig in from the DCC?
Yeah, I mean, I think we try to address a lot of aspects. I mean, I can go back to the so there are different task forces, and for sure we have not addressed everything. And I mean, so I think if you look at all these task forces, key technologies, AI, transportation, I mean, we have mentioned them, but it's things, how AI, how can it transform green electronics? So that's something that has been addressed. I think 2021, the strategic research and innovation agenda was written by EPOS, but that was the big AI explosion happened actually late last year, beginning of this year. So there needs to be an update of, okay, where are we now in terms of the current explosion of ChatGPT and so on. So not everything. So there's still a lot of room for expanding the document.
Do we have any questions or comment from participants here?
Hello, this is, can you hear me? This is Dag Forsén from Norrköping Science Park.
Yes, we can hear you.
Thank you for the presentation, very interesting. I have a question, where do you think, in which industries and application will this happen if we would like to see the development towards more sustainable electronics? Are there any particular places that you can see some some progress already now?
You mean like a specific industry,
Yeah.
like you mean research institutes, or
you see that some industries could be companies that adapt new technology quicker than others, you know, early adopters of this?
Yeah, so I mean, for me, I think there is a lot of positive progress. So printed electronics, for example, is one thing that's moving. Hybrid electronics. There is also modularity being involved in a lot of electronics as well. In-molding is something else, also like having like an in-mold electronics. That's also an industry that's growing, and that has been mentioned in the paper as well. So overall, I think, yeah, like all aspects or all sectors can move forward, and as you mentioned, adapting new things, for example, AI will be critical. So how can we have data science or artificial intelligence to support and promote not just like really actual lab work, but also office work as well? How do we speed up our work? How do we make our machines more efficient? How do we monitor the progress? So one thing we identified is doing life cycle assessments is not easy because you need a lot of data, you need a lot of time. So for example, how can we make automatic life cycle assessments every time something changes? Because life cycle assessment really looks at each component of a product. So if something changes, the life cycle assessment will also change. So how can we automate these processes so that we can have information about the sustainability of products at the get-go? So I think we have the tools, or the tools are really getting better and better. And like you said, we have to use them properly and quite fast.
Thank you, Dag.
Thank you.
We have a question from Ursula as well.
Yes. Yeah. Hi, everybody. I was thinking a little bit about how can we do it as efficient as possible. I think you have really pointed out all the components and all the parts that needs to be in place to go forward. But have you come across like, I'm just thinking of legislation is of course one of the components there, and also new business models. But I'm just thinking of what can be the really most efficient way to speed up the pace here. Could you say something about that? Yes.
Yeah, like you mentioned, legislation is important, but I think we need more transparency. So I think that's really what's limiting, for example, in terms of repair. If somebody wants to repair a phone, if that thing is opened, it loses its warranty, or it's not clear what kind of products, what kind of items are being used inside this product. So it's not easy to repair it. So a lot of transparency and building information is critical. I think that's one of the main things. If we go maybe to the French repairability index, it has like these criteria which are quite, I think, important and detailed. So it's so also pricing and really supporting and giving bonus programs to aspects which can be repaired, or like products that can be repaired. So unfortunately, a lot of the change will only come if there is motivation from legislation or motivation from price. So I think it's those things need to be quite addressed for an efficient and fast change.
Okay. Yeah. Thanks a lot. Thank you.
Thank you, Ursula.
Who will work on the repairability index?
So this has been, I mean, in France, it's already there. So this has also been produced to the EU, not REACH, but let me remember that acronym. But yeah, so like the EU legislation is working on it. So it's but it's not accepted yet by the European Council. So it's not there yet. But like these things take time. So I mean, we started having energy efficiency ratings on our dishwashers and washing machines, I think. I mean, after years of discussion, so hopefully this also comes in soon. Yeah.
Is there any other kind of index you need? Cyclability index, for example. Today there is a need to recycle more than 50% of electronics. So depending on how you design your equipment, you can increase or decrease this cyclability.
Yeah, so what the paper also proposes is that there is a clear guideline using this, call it 10R, 9R framework, so that there is a regulation for each aspect. So, how much should be recovered or recycled or repurposed? So it's having a clear design plan from the get-go as a legislative requirement. So that has been suggested, but it's I think that will even take longer time because there is also no clear example. So the French repairability index is quite good because it has the French government has been proactive and started it. So there's also a need, like you said, what can the DCC do? I think being proactive and coming up with standards and being an example is very important.
And I think that are some good ending wordings. To be proactive and come up with ideas for new standards, maybe is one of the roles for the DCC. Thank you very much, Dagmavi. Really, really interesting. I hope that we can continue on this track.
Yeah, thank you. I mean, thanks for inviting me and that I could talk here. So
thanks.
Yeah, thanks a lot.
Bye, everybody.